All right, so let's go over that review worksheet that I posted. All right, we'll just kind of work through this here. And for number one, it's asking to find the exact value of the sine of 75 using a half-angle identity. Well, what that means is we're going to be looking at the sine of 150 dividing by 2, and the formula is going to either be plus or minus the square root of 1 minus the cosine of 150 and divided by 2. Well, 75 is in the first quadrant, so the answer is going to be positive here. And 150 degrees puts us right here. So we have 1, 2, and root 3. So we're going to have 1 minus the cosine, which is negative root 3 over 2, over 2, which is, we can multiply top and bottom by 2 here. We're going to have 2 plus root 3 over the square root of 4. And that would be our final answer. For the cosine of 165 using a sum and difference, well, 165, we could use 120 and 45. And according to the sum and difference formula, we take the cosine of the first, cosine of the second, opposite sine, sine of the first, sine of the second. So 120 I just drew before, 120 is over here. And 45, we know what 45 looks like. So the cosine of 120 would be negative root 3 over 2. Cosine of 45 is root 2 over 2. Sine of 120 is 1 over 2. And sine of 45 is root 2 over 2. So if you multiply this out, you would get negative root 6 minus root 2 all over 4. Next one is the tangent of 75 using any identity that you know. Well, 75 is, we did that with number 1, the first problem, sine of 75, so I'll just use a double angle. It doesn't matter which one we do. So this would be the tangent of 150 over 2. Again, we're in the first quadrant. And looking at my formula sheet for a half-angle identity, one of the formulas that we could use would be 1 minus the cosine of x over the sine of x. So here's 150. And this would be 1 minus the cosine divided by the sine. Dividing by 1/2 is the same thing as multiplying by the reciprocal. And that would give us the answer of 2 minus root 3. Actually, you know what? The cosine, I forgot to put a negative here. So we'll just kind of fix this up a little bit here. That would be the answer, 2 plus root 3. All right, so now let's go to number 2. Problem number 2, it's asking us to find the sine of a minus b. The formula for this is sine of the first, cosine of the second, same sign, and then cosine of the first, sine of the second. And it's saying that for angle A is in the third quadrant, and the sine is negative 5 over 12. And B is also in the third quadrant, and the cosine is negative 3 over 5. So this would have to be -4. And for number 2, unfortunately for A, we have to use Pythagorean theorem. And just doing this quickly here. Let's see here. We have 119. So this would have to be negative square root of 119 using Pythagorean identity. All right, so now let's go ahead and plug into our formula. All right, so sine of A would be -5/12. Cosine of B is -3/5. Cosine of A is -√119/12. And sine of B is -4/5. So cleaning this up here, we get 15/60 minus 4√119/60. And we could combine the whole thing, 15 minus 4√119/60. That should be the answer. That's where it comes from. All right. If you have any questions, just yell them out. It's a joke. Right. All right. So number 3, it says use the provided triangle to find the double angle identities for all 6 trig functions and the half angles. All right. So this will be fun. Here's our angle. We have 5, 12, and 13. First thing let's do is let's do the double angles. So the sine of a double angle was 2 times sine of x cosine of x. We're using theta here. It doesn't matter, but let's just try to be consistent. All right, Brad, that sounds good. All right, thanks, Brad. Just a little dialogue with myself here. So the sine would be 5/13. And cosine would be 12/13. So if you multiply that out, that would be 120/169. So the cosecant of this double angle would be the reciprocal, 169/120. The cosine of a double angle, we have 3 different formulas. Doesn't matter which one you use. I'm going to use 2 cosine squared of theta minus 1. So 2 times the cosine is 12/13 squared minus 1. If you type it into your calculator, this would come out to 119/169. And the reciprocal would be 169/119. And the last one, let's do tangents. Tangent of 2 theta. So we have a few different formulas. Actually, no, not really. That's the half angles, but double angle, the formula was 2 times the tangent of theta over 1 minus the tan squared of theta. So 2 times the tangent divided by 1 minus 5/12 squared. So if you just do the arithmetic here, it'd come out to 120/119. So the cotangent of 2 theta would be 119/120. All right, and then I also had asked you to do the half angles. So the sine of a half angle, we don't know if it's going to be positive or negative here, but according to our formula, the formula is plus or minus the square root of 1 minus the cosine of theta over 2. Well, the cosine looking at this triangle would be 12/13. And if you do the arithmetic here, that comes out to plus or minus the square root of 1/26. And if we rationalize by multiplying the top and bottom by √26/√26, the answer comes out to be plus or minus √26/26. For the cosine, similar formula. It's going to be 1 plus the cosine of theta over 2. It's going to be plus or minus the square root of 1 plus 12 over 13 over 2. If you do the math, that comes out to plus or minus 25 over 26. And if you rationalize it by multiplying by the square root of 26 over itself, on top, you would have 5 times root 26 over 26. All right, and the last one here, a tangent of theta over 2. Let's see here. We have a few different formulas. We could use 1 minus the cosine of theta over the sine of theta, which would be 1 minus the cosine over the sine. We can multiply top and bottom by 13 to get rid of all these fractions. So 13 minus 12 over 5 gives us an answer of 1/5. All right, so now let's go to number 4. So for problem number 4, the first one, it says sine of x over 2 plus the cosine of x minus 1 is equal to 0. So let's make that substitution. Sine of x over 2, let's see, what is that? Sine of x over 2. It's going to be plus or minus square root of 1 minus the cosine of x over 2. In order to get rid of this, we should bring these other two terms on the other side. Square both sides. We get 1 minus the cosine of x over 2. If you FOIL this out, you get 1 minus 2 cosine of x plus cosine squared of x. Multiply both sides by 2. And let's get everything on the same side so we can make it equal to 0. Cosine squared of x minus 3 cosine of x. Bring the 1 over plus, let's see, I was moving too fast here. Multiply everything by 2. This would actually be 2 cosine squared. That's why I was going rocking and rolling a little too quickly here. 2 sine squared of x. Bring the plus cosine of x over. That would turn into negative 3. Bring the 1 over. This would just turn into 1. So now let's go ahead and finish it. This would factor be 2 cosine of x. Cosine of x. 1 and 1. If this is negative and this is negative, this would be negative 1 cosine and negative 2 cosine, so that's factored correctly. Set the factors equal to 0. And in order to get cosine of 1/2, that would, let's see here, when is cosine 1/2? Well, that comes from our 30, 60, 90 triangle. And cosine of 1/2 would happen at 60 degrees, or all students take calculus, 60 degrees and 60 degrees right here. So 60 degrees would be one answer, another answer would be 300 degrees, and we add the period. And it looks like we have x here, so x means we should use radians. So 60 degrees in radians is pi over 3. And 300 in radians is, let's see, 300 is 5 pi over 3. Now, when is cosine of x equal to 1? Well, that's the x value, so it's 1 right here, it's 0. X would be 0. radians plus the period. Now you could also say 2 pi. I mean, it's the same exact thing. 0 and 2 pi are both right here. So either one of those answers is fine. The three answers that I would accept are these. Those are the correct answers. All right, so we have one more to go here. Let's do the last one. It says sine squared of x plus the cosine of 2x minus the cosine of x. Now, it'd be a good idea to get all the same trig functions. So I see cosine here. I'm not going to be able to make that into sine. So let's go ahead and if sine squared plus cosine squared is 1, then sine squared would be 1 minus cosine squared. Cosine of 2x, we have some options. I'm going to use the one that uses cosine. So that would be 2 cosine squared of x minus 1. And then minus cosine of x is 0. So now let's straighten it up and see what we wind up with. One minus one's cancel. This would just give us cosine squared of x minus cosine is equal to 0. So what word rhymes with tractor? Factor. Very good. So when is cosine 0? Cosine's the y value, so that happens, or I'm sorry, cosine's the x value. It happens at 0 degree, It happens at 90 degrees, and it happens at 270 degrees. But because we're using x, we're going to say the answer is pi over 2 plus the period, and we're going to say 270, which is 3 pi over 2 plus 2 pi k. And the last one, when is cosine of x 1? We just talked about this in the last problem. Cosine's the x value, it's 1 right here. So we could say another answer would be 0 plus 2 pi k. Those would be the three answers that I would accept. All right, that's it. Stay tuned for today's lesson.